Let's discuss cholesterol metabolism. In the intestine, cholesterol absorption determines what percent of the dietary cholesterol and what percent of the biliary synthesis of cholesterol is actually going into the blood. Now, the absorption of cholesterol is a diffusion-controlled process. Diffusion-controlled process. And the removal of unwanted cholesterol from the enterocytes back into the lumen is modulated by the ABC protein. ABC stands for ATP binding cassette. Now, these ABC proteins utilize ATP to move cholesterol out of the intestinal cells. Now, the increase in ABC protein also increases the excretion of your cholesterol into the gut. Remember that your cholesterol cannot be metabolized as carbon dioxide and water. Hence, any excess cholesterol is excreted into the feces. Now, we have different types of ATP binding cassettes. So, we have your ABC1, ABCG5, and ABCG8. Now, people with deficiencies or abnormalities with the ATP binding cassette proteins have elevated cholesterol levels, which predisposes them into increased risk in cardiovascular diseases because the excessive amounts of cholesterol into the enterocytes eventually reach the blood. And as what we all know, kapag mataas ang levels ng cholesterol in the blood, dyan na nagsisimula yung formation ng plaques and atherosclerosis, which can eventually lead to death or stroke or myocardial infarction. In the body, most of your cholesterol exists as cholesterol ester. With the carbon number 3 being esterified kasi siya yung merong hydroxyl group. Now, the precursor of your cholesterol is acetyl-CoA, and you will be needing NADPH for its biosynthesis. Now, it is important to note that the biosynthesis of cholesterol happens in the cytosol. So, tignan natin, isa-isahin natin mamaya kung paano ba or ano yung mga reactions na nangyayari. NADPH comes from the reaction catalyzed by glucose 6-phosphate dehydrogenase and 6-phosphogluconate dehydrogenase. So, ito, yung dalawang yan ay makikita sa hexose monophosphate shunt. Now, the biosynthesis of cholesterol has 4 major steps. So, number 1 is the synthesis of mevalonate. Number 2 is the conversion of mevalonate to active isoprene units. And then number 3, we have the condensation of the 6 activated 5 carbon units, the isoprenes, to form 30 unit carbons. And number 4 is the conversion of squalene to steroid nucleus. Now, the first step which is the synthesis of mevalonate, is catalyzed by your HMG-CoA reductase. This step, yan, is the rate limiting step. Now, for the second step, yung active isoprene units natin, dalawa yan. So, we have your dimethyl, allyl, pyrophosphate, your DMAP, and your isopentenyl pyrophosphate. So, that's your IPP. So, yung dalawang yan, yung nagko-condense in the initial step to form your C10 geranyl pyrophosphate. So, tignan natin mamaya yung specifics. Now, ito, sa third step, yung C30, that's your squalene, which eventually, in the step 4, na i-convert mo into the steroid nucleus. So, now, let's take a look at the different reactions. So, in the first step, diba, yung formation ng mevalonate. So, una-muna, you have your 2-acetyl-CoA units, acetyl-CoA plus acetyl-CoA, to create your acetyl-CoA. Now, from this, magdadagdag ulit tayo ng acetyl-CoA to form your HMG-CoA. Now, yung HMG-CoA formation is catalyzed by the enzyme HMG-CoA synthase. Now, you have to take note na narinig nyo na yan, di ba, yung HMG-CoA synthase. Nakikita din yan sa mitochondrial matrix, but it's a different HMG-CoA synthase na nakikita sa cytosol. Kasi itong cholesterol biosynthesis sa cytosol to nangyayari. Now, HMG-CoA is then converted into mevalonate by the enzyme HMG-CoA reductase. Now, the conversion of the HMG-CoA to mevalonate needs NADPH. So, dalawang NADPH yung i-oxidize natin into NADP+. Now, ito yung major control point, yung HMG-CoA reductase. Now, what are the different control points for HMG-CoA reductase? So, number 1, it's your transcriptional control. Number 2, you have your proteolytic degradation. And number 3 is through covalent modification. Tignan natin yung iba't ibang control points. So let's first start with transcriptional control. With the transcriptional control, meron tayong proteins na involved known as your SREBP. Now, your SREBP stands for sterol regulatory element binding protein. And your SREBP enhances, specifically yung SREBP1A enhances the transcription, the transcription of genes for the reductase enzyme of genes for HMG-CoA reductase. Okay. So, ano bang ginagawa nito? Your SREBP protein is an integral protein that can be found in the smooth endoplasmic reticulum. So, if this is your smooth endoplasmic reticulum membrane, so nandito yung SREBP. Okay. Now, once na-synthesized, hindi pa siya talaga active, no? So, you have other proteins which activate your SRBP, and these include your SCAP, SCAP, okay? And your S2P, S2. Now, your SCAP stands for SREBP, cleavage activating protein. Cleavage activating protein. Whereas your S2P stands for site 2 protease. So, ang ginagawa nila, no? So, kinikleave nila yung SRBP. Okay? Ayan. Silang dalawa. Para ma-release siya dun sa membrane. And then, once released, okay? So, once released, it will go into the nucleus, which then binds to the SRE. SRE stands for sterol regulatory element. So, meron kang portion ng gene, which is your SRE, kung saan nagbabind itong SREBP, tapos mag-i-increase na yung transcription. Hence, increase in HMG-CoA reductase, increase in cholesterol synthesis. Increase in cytosolic sterol actually inactivates your SCAP. So, kapag ka ini-increase mo yung cytosolic sterol, ayan, yung SCAP, doon nagbabind yung cytosolic sterol, tapos ini-inactivate niya yan. Kaya, nababawasan din yung transcription ng HMG-CoA reductase. Now, the second control point is proteolytic degradation. Now, kapag ka nag-i-increase yung cholesterol sa cytosol, it causes the change in oligomerization of the membrane component of the HMG-CoA reductase. So, itong change in oligomerization makes the enzyme susceptible for proteolytic cleavage. Now, the third point of control is covalent modification. Actually, this is just phosphorylation, dephosphorylation, dephosphorylation. So, ngayon, once your HMG-CoA reductase is phosphorylated, it is inactive. And if it is dephosphorylated, it is active. Now the enzyme which catalyzes phosphorylation is your AMP, activated protein kinase. So, AMP activated, kapag mataas ang AMP, ang initial na mangyayari is phosphorylation. So, therefore, bababa yung activity ng HMG-CoA reductase. Kasi, kailan ba tumataas ang AMP? Kapag mababa ang ATP, mababa ang energy yield or yung energy content ng cell. Ngayon, ano pa yung nagkakos ng covalent modification? Increase in glucagon, increase in phosphorylation, and mababa ang activity. Kasi, kailan ba mataas ang glucagon? Kapag gutom ka in the fasted state. So, bakit ka nga naman gagawa ng cholesterol na kinakailangan mo ng energy, kulang ka na nga sa energy. Also, increase in intracellular sterol also decreases the activity of your HMG-CoA reductase through increase in phosphorylation. And also, increase in thyroid hormone. Ayan, pag mataas naman ang thyroid hormone mo, mag-i-increase ang synthesis ng cholesterol. Okay? And then, kapag ka naman mataas ang glucocorticoids, increase in glucocorticoids, bababa naman ang activity kasi nag-i-increase ang phosphorylation. Let's continue our discussion on the metabolism of cholesterol. So we start with mevalonate. So after the limiting step, now mevalonate is converted to isopentenyl pyrophosphate, which isomerizes into dimethylallyl pyrophosphate. Now, the conversion of mevalonate into isopentenyl pyrophosphate requires 3 ATP. The structure of isopentenyl pyrophosphate is this 5-carbon unit with the pyrophosphate attached at the end. And we also have your dimethylallyl, which is the same in structure except the position of double bond is different. So let's have the following structures of your ITP, and down here is your DMAP. Now, between the two, it is your DMAP, which is electrophilic, because once your pyrophosphate leaves, pyrophosphate is a good leaving group, your carbocation is stabilized by resonance. Unlike in your ITP, hindi na magkakaroon ng resonance once na umalis yung pyrophosphate. So, nakastay lang or nakalocalize lang yung positive charge. So, between the two, it's your ITP that acts as a nucleophile and your DMAP, which acts as an electrophile. So these two, your DMAP and ITP, combines to form your geranyl pyrophosphate, which is a 10-carbon unit. Geranyl pyrophosphate with the subsequent release of inorganic pyrophosphate. Now, geranyl pyrophosphate forms your farnesyl pyrophosphate, which is a 15-carbon unit, by combining with one molecule of ITP. Now, your farnesyl pyrophosphate combines with another molecule of farnesyl pyrophosphate, which is a 15-carbon unit, with the subsequent release of two inorganic phosphate to create your 30-carbon unit. Now, that 30-carbon unit is your squalene. 30 carbons. Now, squalene, with the help of your oxygen and NADPH, produces squalene 2,3 epoxide. Squalene 2,3 epoxide, which is the precursor for lanosterol. Now, lanosterol is the precursor of your cholesterol. So that's how you synthesize your cholesterol from acetyl-CoA.